This video covers the final exam review day 3, part 1. So this is pages 1 through 3. If you want pages 4 through 6, that's on the second video. So part 1 asks us to complete the table of values, state the asymptote, domain, and range of the exponential function. So remember, axis is kind of like your vertex. It's the opposite of what's inside with x, the same as what follows. So we have nothing inside with x, the same as what follows. Now, to see your asymptote, domain, and range, if you've forgotten what these look like, you can go to y equals and type them in exactly like you see them. So 8 raised to the x minus 4. I can see that this one has a horizontal asymptote. So it's going across. My horizontal asymptote is at -4. If you're not sure if it's horizontal or vertical because this one is going up, then you can see in your table where your y values hit. Or you can also look in your x's. It kind of looks like we might have an asymptote here, but it actually doesn't have an asymptote because we have all these x values, and if we didn't have an x value, then there would be a problem, but there are x values. Okay, so our asymptote is at -4. My domain for this is going to be all reals, and my range is going to be greater than or equal to my asymptote. So problem 2, my axis is the opposite of what's inside with x, the same as what follows. My asymptote is going to be a y asymptote. Domain is still all reals, and then my range is greater than or equal to -4. So here, to complete it and sketch it, the part that comes into play with sketching is the whatever x is raised to. So my axis is 0, -2 because there's nothing with x and a -2 that follows. This one is going to be decreasing because of the fraction. If it's less than 1, it's decreasing. If it's greater than 1, it's increasing. Asymptote is going to be at -2. Domain is all reals. Range is greater than or equal to -2. Again, if you're not sure, you can plug this in exactly like you see it. We have 1/3 raised to the x, and then a -2 afterwards, so we can see what it looks like. We can see it's coming down and stopping down there at that asymptote at -2. So my asymptote at -2 goes across like so. My axis is at 0, -2. So that's where my asymptote goes through, but also where my graph starts to turn. And this one is decreasing, so it will go down. Remember, your graphs do not have to be exact as long as you have the general idea of what it looks like, and it needs to look something like the graph on the calculator. So for problem 4, we don't need the calculator anymore. My axis is going to be 0, -5. So that's where it's going to turn, and we have an asymptote going through there. This one is going to be increasing because of the 5. Domain is still all reals, and range is greater than -5. So because this one is increasing, we're going to come in at the asymptote and then slide up once we get to that x value. Now for these problems, your growth and decay formula is your A for initial amount, 1 plus or minus your rate as a decimal raised to the t. So problem 1, we bought a condominium. Its value is appreciating, so it's growing. How much will it be worth in 5 years? So my equation is going to be my starting amount. It's appreciating, so it's growing. My rate at 0.06, and you can either put to the t or put the 5. Some people like to write the equation as the full thing. My answer is going to be whatever I type in this whole thing. So 83,000, 1 plus 0.06. Remember, you have to turn that into a decimal. Raised to the 5 years. So my answer, this will be worth $111,072. We'll do 73 and just round it at dollars. So this is something that you would definitely want to write on your note card because a lot of people struggle with remembering that formula, and if you have that formula, you'll know how to use it. Problem 6, we're talking about a violin that starts at 1.7 million. It's increasing by 7.5%. So my equation is 1,700,000. 1 plus 0.075 as a decimal to the t. Now my t, we started in 1990. It's now the year 2010, so that is 20 years. So remember, sometimes t is not immediately given to you, and you actually have to figure it out. So from your starting date to your ending date is your t value sometimes. So I plug this in exactly like I see it using a t of 20, and my answer is 7,221,347. Problem 7, we have a celebrity that starts with 150,000 followers. It's increasing 35% for years. So we start with this 1 plus, because it's increasing 35%. We Beyonce it to the left, so 0.35 raised to the t, and t is 4. So in the calculator, 150,000, 1 plus 0.35 raised to the 4 is 498,226 followers. Now we have a growth or decay formula chart. They're asking us, is it growing or decaying? If it has a plus sign, it's growing. If it has a minus sign, it's decaying. If the number in parentheses is bigger than 1, it is growing. If the number is less than 1, it's decaying. Your initial value is that starting number right in front, so 1,200, 55, 100, 5575. And then your rate is either what's being added to it, or what made it bigger than 1, or smaller than 1. So on problem 10, we have 1.25. Remember, we do 1 plus your rate. So if I have 1.25, it means they added 0.25. Decay, we do 1 minus the rate, and we got 0.65. So we're going to do 1 minus 0.65 to figure out what they subtracted from 1 to get 0.65. So 0.35. Those can also be written as percentages if you want. To write things from logs to exponential form, remember we start inside, go across to 7. When we cross the equal sign, we write equals, and then we write whatever it equals. So we started at 2, we go out to 7, so 2 raised to the 7. We cross the equal sign, so we rewrite the equal sign, 128, so we write 128. This can easily be checked by plugging in 2 to the 7 in your calculator and making sure it does equal 128. Now, all they wanted us to do was write it, so we leave it in this. This is exponential form because you have an exponent. So for this problem, we start out at 8 and go to 2, cross the equal sign, and go over to 64. And a quick check reminds us that 8 squared is 64. Still going in exponential form, 4 to the 4 equals 256. And 8 to the 3 equals 512. 16 through 19, they ask us to plug into exponential form and solve for x. 17 and 19, we're not going to do the instructions. I'll show you what we're going to do in a minute. 9 squared equals x is how we would write 16, so we've written it in exponential form. And then to solve, I'm just going to plug in 9 squared. So x equals 81. X cubed equals 64. To uncube x, we take the cubed root. So we go to math, scroll down to cube root. We want the cube root of 64. So x equals 4. Now for 17 and 19, we're going to do these in the calculator. So our steps are to click Alpha Window 5. And we type in what we see. Now remember, if there is no base shown, it's a base 10, not 1, but 10. So we do it again. Alpha window 5, we have a little 8 and a big 1, so x is 0. So sometimes I can just show you real quick. This 10 to the x equals 10, 8 to the x equals 1. If you rewrite it in exponential form and have an x in the exponent, it means it would be easier for you to take what you had originally and plug it into the alpha Windows 5 log option. Okay. Now remember, we can also use that alpha Windows 5 log option, to type in what we're seeing to graph. So we have log base 3 of x plus 1. We can graph it and remind ourselves that it has a vertical asymptote this time and goes across. So my axis is whatever the opposite is with x. X has nothing with it. It would be in parentheses if it did. Asymptote this time is in x equals, so my domain is greater than my asymptote, and my range this time is all reals. So my axis is at 0, 1. My asymptote goes through 0, and my graph, as we saw, comes up and goes across. You can remember that it goes up because the base, whatever the base is, tells you if it's increasing or decreasing. So 21, my axis is the opposite of what's with x, the same as what follows. So my axis is going to be at 4, 0, and my asymptote is at 4. Domain will be greater than 4, and my range will be all reals. This one has a fraction as the base, so it will be decreasing. And again, you can plug this into y equals to double check that if you're not sure if you've graphed it correctly.